what is covered in these fundamentals of testing? The fundamentals of testing covers what is testing, why testing is important, what types of testing is there, why we see the software fails. We know that everybody is working, everybody is paying attention and working, but we still see defects or the bugs we call, and that's why we need testing. So what is testing? Why testing is required? This will be covered in this first chapter. It also covers the activities we do during our testing, like test planning, monitoring and control, test analysis and design, test implementation, test execution, test completion. It also covers the phases of testing. Yes, what are the things we do during these phases? This will be covered during the first chapter. We also need to understand what mindset we have to have as a tester.
Okay.
So the mindsets as a tester, this will be covered during in this chapter. It also covers about the psychology, means mindsets, and the levels of independence. What types of independence, what levels of independence we have by the person who is testing the software. And as a tester, you need to have some qualities. So we will discuss the qualities we have to have as a tester. Yes. Chapter 1 covers these topics. Chapter 2. Any question with this chapter 1?
No.
So in chapter 2, you can see testing through the life cycles. So whenever we develop a software, yes, whenever we develop a software, we can't just start and finish it. We have to have the methodologies. Yes.
Okay.
So what are the methodologies we have when we develop a software? So there are a few models there we will cover in this chapter. One of them is called Waterfall Model. What is waterfall? If you try to understand the word itself, you can see waterfall means water comes from the top and it goes in, yes, down.
Yeah.
So exactly the same way the whole software is built and you test it. So the whole software will be built first and then in the end you carry on testing. Yes. So as for example, you have a whole software, UI, everything done, database development, backend development, front-end development is done, and at this stage you start testing. You don't know what actually the customer wants. You don't know actually what the business wants. In this scenario, what happens? The software can be built totally incorrect. Yes, it might not be meeting the requirements. So I give you two examples. If you are interested in testing, then you can watch some of the videos on Guru 99. In Guru 99, there is a girl. So a young child wants a swing hanging on a tree, and the requirement was written in a way that a tire was there. Yes, a tree is there, but there is no rope or string which is tying the tire with the tree. So what happens? The picture is says that something is missing there. Yes. Another example is that sometimes there was one requirement came that I want paint me an animal which is small in size. Yes. Which has a small tail, which has a trunk. So the requirement was written in a way that the person wanted a baby elephant, but in the end somebody build it or draw not interpreted correctly, then the whole software will be incorrect. Yeah, so this is the drawbacks of waterfall. So we will cover what is waterfall model, how testing is done in waterfall model in detail. Next is V model, we call it. Why it is called V model? In this model we do two steps of testing. One is called verification and validation.
Which model is this?
V model.
VModel.
So if you do verification and validation, the shape of becomes V, because we have parallel testing activities compared to the development activity. We have some of the development activities for the particular level. We have testing activities, and its shapes is like V, and that's why it is known as V model. So what happens in this V model? This is one of the best development models. Nowadays nobody is using, people are using, organizations, but not many, but one of the best it used to be. So in the initial phase you have the component, small components. Yes, so for that you have the component requirement. Yes,
Okay.
for the particular phase you will have component test plan and you will do component testing. Next phase is design specification, how the software, that for that you have component integration testing, test plan, and you do component integration testing. Then all these components are integrated, so you will have the system. So you have the system specification or system requirement, and for this phase you have system test plan. For that you do system testing. After that you might be using few systems merging together to develop one system. So for that you have integration specification. You are integrating the systems, how you are going to integrate. Yes, so that is called integration requirement or integration specification. For that you will have the system integration test plan, and then for that you do testing. It is known as system integration testing. In the end or high level you have the business requirements or the business specification. For that you have the acceptance test plan and you will do acceptance testing, which is known as UAT.
UAT.
Yeah, user acceptance testing,
Okay.
or you can just simply call it acceptance testing. So what happens in this scenario? If you be a tester in any organization, you won't be doing everything. If you get a job as a UAT, then for the rest of the life, whenever you are in that organization as a tester, you will do only UAT, user acceptance testing only. Component testing as a tester you will not do it. It is done by the developers. System testing, how the system functionalities work. Based on your job role you will be doing this stuff. Okay, there are other models. They are all covered in one of the section called iterative incremental models. Okay,
Iterative.
iterative incremental models. Why we call it iterative incremental models? We call it waterfall V model, but here we call it iterative incremental models, because in this particular category we have number of models. One is called Scrum, which I am working on Scrum. Okay, Kanban, Rational Unified Process or RUP, and Spiral or Prototype. These models are also known as agile models. Okay, so if you go through or read the requirements for a testing role, test role means positions, they will put you should be able to, you should have experience of working in agile model. So when they say agile, they might be using one of them. But most of the companies, not most of the companies, it depends on the requirements, it depends on the specification. Based on that, they select one of the models. They are similar. What happens in these models overall? You have the whole software. The whole software or the system requirement is broken down into the small pieces. Okay, one piece of the software is developed or built, tested and released. That particular piece of the software should be working as per the requirements. Then we will go to the another section or another requirement or another specification, build and release it, and this is how the whole software is built and released.
Okay.
It depends on iterative, we call it. So it has the iteration, the small time period. As I said, they are known as iterations. The iterations can be from 2 weeks to 4 weeks. Okay, if we read the ISTQB syllabus, is the standard format is of 2 weeks to 4 weeks. We are having 2 weeks at present. Some of the organization they use 3 weeks, other 4 weeks. But if the project is big, very big, complicated, then some of the organizations they use 6 weeks time period in this agile model. So you select requirement as, for example, login requirement or registration requirement or posting a course requirement. This particular section of area will be selected in one iteration, and it will have a time period 1, 2 weeks, 3 weeks or 4 weeks or 2 weeks. In this particular, the whole software means the particular part of the software will be built, tested and released, and it should be fully functional. Yes, any questions so far with this?
No.
The next, it covers component testing. In component testing, it has some drop down, no, top down, bottom up approach. So this chapter also covers these approaches we use in the testing. In integration testing, how we integrate the modules and it will be tested, what are the approach we use for integration testing. This chapter covers this one. We will discuss in detail how the system testing is done, what are the things we have to keep in mind doing acceptance testing, and the test levels. What are the test levels, why we need to do testing, what are the requirements we have for the acceptance testing. It also covers functional testing, non-functional testing at a high level, not in detail. And the next chapter will cover the functional testing and non-functional testing in details. So let's discuss to the next chapter. The next chapter talks about test design techniques. So I give you example. One of the testing principles we cover in fundamentals of testing is exhaustive testing is impossible. We cannot do complete testing. I always give example of Euro Million lottery. Okay, if you have any knowledge about the Euro Millions, In this euro millions, you have 5 numbers, which is 1 to 50. I'm not 100% sure. Okay, 1 to 50, and there are other 2 numbers. Call it lucky dip, not lucky dip or star. I don't know so, but there are other 2 numbers which cover 0 to 9.
Okay.
Yes, these 7 numbers, you have the combination. If you want to test the complete combination of this euro million lot list, there are 77 or 78 million probabilities. I read long time back, so forget about the number exact, but say 77 million probabilities. So if you buy 77 million lines, you definitely win euro millions. Okay,
Okay.
when you are testing this euro millions, will you be able to test this completely? No. Yes,
Yeah.
no software can be tested completely. As for example, I give you one simple example of the mortgage calculator. Mortgage calculator based from your deposit, based on deposit, how much you are borrowing, and house price or the property value. Yes, how property price. You can
Yeah.
have 1%, 2%, 3%, 4% property value from 10,000 to millions or billions. Yes.
Yeah.
So you have different combination. You won't be able to test it. Then what happens if you can't test the software completely? Then you might be missing something. If you don't want to
Yeah.
miss it, and because of that, we have to use the techniques. So we have 3 categories in test design techniques, like black box, white box, and experience based. So what is black box? You can't see, you don't know. You have the specification, you design the test cases, and you are testing the software, which is covered in black box. White box, you have the knowledge of the code, how the actual code works. Based on that, you design the test cases and test it.
Okay.
White box. Now you have experience of working as a tester. So based on your experience, you will be testing the software. Yes,
Yeah.
that is known as experience based technique. So based on your experience, you will be able to tell what needs to be done. Yes, what
Yes.
testing is required. So what is covers in black box technique? In black box technique, there are 4 techniques: equivalence partitioning, boundary value analysis, state transition testing, decision table testing. White box testing covers
I'm writing. Can you in black box? Which 4 contain?
in black box, there are 4 techniques I will cover in detail when we go to, but it covers equivalence partitioning,
Equivalence partitioning,
boundary value analysis, state transition testing, and decision table testing.
decision table testing.
Yes, these are the techniques we use in black box.
Black box.
There is another one also called, yeah, I covered state transition testing. Let's go to the white box testing. So as I explained you earlier, what is white box testing? White box means you can see the code
Code.
and
Yeah.
you design, you have the terminologies, you have the knowledge of internal structure of the software. Okay,
Yeah.
but it is easy to understand when I use the word you have the knowledge of the code. So there are 2 techniques to test. One is called statement testing and decision testing. Yes, so you have studied some of the programming languages, so you know the statement. Yes, the
Yeah.
executable statement you have in the programming, so you are particularly concentrating and testing the particular statement. Decision, based on the condition, you might be making some of the decisions. Yeah,
Yeah.
so this is known as decision testing. In black box, we have decision table testing. This is decision testing. What is decision table testing? Based on the requirements, you make decisions and you test it. I give you very good example. You have a child now, so I can give you. You have the boots card. Based on the items you buy, you are given some points. Yes. Based on the points, you can buy something, and you make decisions and you allocate some point. This is based on decision table testing. Here, based on the code, you make decisions. That's why you known as decision testing. Yes. The last one is called experience-based technique, and it covers exploratory testing. So based on your experience, you explore the system. Yes. And try to find out the bugs. Based on an yes.
Try to find out the
defects or bug. Bug means defect. Something is not working. Error guessing. Based on your experience, you can say in this area you will have error. Yes. Checklist testing. You based on your experience, you make a list. This is what you need to cover, and you do testing. It might have a formal approach or informal approach for experience-based testing. Any question with this one?
No.
Chapter 4 covers static techniques. So what is static techniques? Whenever we talk about the testing, we always think of the UI stuff. Yes. But testing the UI, whenever I tell you, okay, test something, then you will think, okay, you might be logging into the application, you might be doing some calculation, you might be verifying the data, you might be verifying the expected result. Yes? No. Testing is testing both the documents, okay, and system itself. That's why there are two categories in this. One is called static techniques and dynamic testing. Okay, static testing and dynamic testing. So what is static testing? Techniques. Okay, static means testing the documents. So static means testing the documents. So as for example, you wrote some requirements. There might be spelling errors that are simple to find. Yes.
Yeah.
There might be some grammatical errors. Some might be the requirements not written properly. They might be ambiguous. Ambiguous means they might have dual meanings.
Yeah.
So you need to test these documents. Second, you might have analyzed the requirements and prepared the requirements matrix. In that you might not have worded properly and it might have the ambiguity. So your requirements should be tested. Yes.
Okay.
Test manager prepare test plan. The test plan, test approach, test strategy documents, they should be tested means they should be reviewed. Yes. So you find out there is no error in the particular documents. Test case. You as a tester writing the test case. I am as a tester writing the test cases. I am a tester. This is my understanding of the particular requirement. Yes.
Okay.
I might have misunderstood the requirement and the test case might be incorrect. I might have one way of thinking of the particular requirement and might not have covered all the scenarios. Might have missed some of the scenarios. So my test cases should be tested, means reviewed is the word for that. Yeah. So these all things cover in static testing. Next comes is dynamic testing. So what is dynamic testing? Dynamic testing means you are testing the software itself. Yes. So as for example, you go on the website, so testing system. Okay, testing the system. Yes. So as for example, you are given a mortgage calculator to test, then you are testing the mortgage calculator. In static testing, If you're testing the mortgage calculator, means you are testing the requirements, you are reviewing the requirements, how to build, what are the functionalities in the mortgage calculator. Any question with this?
No.
Okay, the next one is test management. You have done so much testing, yes? But what if it doesn't have any result or it is failing? So we have to manage. If we don't manage, we have to manage our income to survive. Yes. In the same manner, we have to manage our testing activities. Otherwise, there are more chances our project will get derailed. Yes. So we have to manage each and every activity in the development phase or the testing, during testing activities. As for example, there are 4 testers. What each individual or each tester is doing, what are the functionalities, what are the scenarios, everything should be managed. Yes, these all things cover in test management.
Okay.
In order to cover this, we have to have the at organizational level test plan, test strategy, project level test plan and test strategy. Yes.
Okay.
In this, there are different roles there: development manager, manager of a test group, project manager, quality manager. They can be known as a different, but they perform different roles at this stage. Yes, we have to plan the activities, then estimate it how much time it is going to take. Yes, for example, if we are given some activities to test, if we have not planned and our management wants to complete this particular activities in 2 weeks time, and what if we spend 4 weeks? Yes, so we have to plan first, then estimate it how much time it is going to take, how much money it will cost, how much human hours will be spent. Control, then you control the activities. If it is no estimate, then monitor it. You need to monitor it. It is going as per your plan. If it doesn't go as per your plan, then what happens? You have to control it. Yes. As for example, you say that you will finish this work in 2 hours. After 1 hour, you realize that you are going to take 3 hours. Then you have to control this activity, change your schedule or whatever you need to do to finish the work on time. If you can't finish, then there will be a plan B. Yes. So this is, so we will cover what planning covers, what estimate covers, what monitor covers, and what control covers in details in this chapter. Yes, this is just the overview. Any question with this?
No.
Next, and the last chapter is tool support. You need to do testing activity, so you need to take help of some of the tools. They are all known as tool support. Yes, as for example, you are writing something. When you are writing something, you are using a pen or a pencil or a book. Yes.
Okay.
When you are using a pen is a tool. When you are using a book is a tool. Yes. So as for example, you are doing any activity, any support you are taking to support your testing activity, that is known as tool support. So what types of tools are there? There are different categories in there. One is called test management tool. Yes, there are so many tools. One of them famous is called ALM, application lifecycle management. There are quite a few. ALM, application lifecycle management. So in simple word, you can say it's a test management tool. Yes, in this you can have manage the requirements, I will explain you in detail, but you can manage the requirements, you can manage the test cases, you can have the test plan, you can have the test sets, and you can do execution there. There is another tool called Jira. Okay, this is specific for Agile. It is also test management tool only, but it's called Agile Test Management Tool.
Agile.
Yes, so if you say that you have worked in an Agile team in your CV and experience, but if you have put ALM, then if experienced test manager reviews it, he can find out or she can find out this is a fake CV, fake experience is there. When you have worked in Agile, then you are going to use Jira, not ALM. Yes.
Okay.
In this category, there are quite a few tools called, yes, defect management tool, requirements management tool. You can have the specific configuration management tool, continuous integration tools. I will cover in detail configuration management tool, but let me explain you. You need to manage your version control, yes, and you need to store these all software by version wise. You can store them in the configuration management tool. Requirements management tool, you can manage all the requirements in the requirements management tool. Defect management tool, you will manage just the requirements in a particular tool, is known as requirement management tools. And the continuous integration tools like Jenkins, you maintain how you improve continuous integration, is called pipeline. Okay, there are called CACI tools, Jenkins, Concourse, like these tools are there. What if I have a question? Your organization is so small and you can't afford buying these tools.
Okay.
Then what will you do now? It's a question I'm asking you. These tools are not free. Some of the tools are free, but most of the tools for an organization is not free. You need to buy. And you don't want to spend so much money, then what will you do? If you don't have money and if you don't want to buy, you can still do. You can just use Excel or Word. Excel is better than Word. So you can use Excel as a test management tool because you can manage your requirements there. You can manage your test cases there. You can manage your test sets there. You can do execution and maintain the reports in an Excel. So if you don't have anything, you don't have money and you do, Excel is a tool. Okay, you use Excel, then Excel is a tool. Or if you are using Word, then Word is a tool for you. Okay, in the end we will learn one thing: a fool with a tool is still a fool. Okay, a fool with a tool is still a fool. So you are given ALM or you are given Excel to use, you are given any tool, Jira, you are given Selenium, Eclipse, IntelliJ. They are the tools, yeah?
Yeah.
But they are known in the different categories. If you don't know how to use them, then it is not worth. Yes,
Yeah.
so that's why. If you don't have anything, you have just Excel, but if you're expert using Excel, then you don't need any of the tools. So how you use a tool is important than what tool available. Okay.
Okay.
So another, tools are not cure for poor testing methods. Tools can't bring you the good result if you don't know. So we have to understand how to use, we have to learn how to use the tool. And the last is, if the only tool you have is a hammer, the whole world begins to look like a nail. You don't have anything, you just have a hammer, then you will just yes, hammer knock everywhere. So the tools are not important, how you use them is important.
Okay.
So this is what we cover in these 4 chapters.